So the last couple lessons were all about the angles, the parts of the circle. We were told about inscribed angles, central angles. Central angles, again, are the same measure as the arc it intercepts, whereas an inscribed angle is half of the arc that it intercepts. So we just have to differentiate between the two. Again, central angle is an angle comprised of the angle created by 2 points off the circle meeting at the center of the circle, whereas an inscribed angle is an angle that is created by 3 points off of the circle. It does not create an angle at the center. The angle is created near the side of the circle. We talked about arcs in a little bit yesterday, so we're going to take a look at arcs and chords more involved with each other rather than angles and arcs. So what's it look like? If we have a circle, congruent circles, two minor arcs are congruent if and only if the corresponding chords are congruent. So what that means is a chord is a segment created by 2 points off of the circle, not running through the center. So FG here is a chord. So here we are told if F chord FG is congruent to chord LH, then the minor arcs are going to be congruent. So in this case, arc FG is going to be congruent to arc HJ. Again, the minor arcs are the smaller arcs created by the two endpoints. Arcs between parallel chords are congruent. So if we have arc FG parallel to arc HJ, then this means arc FG is going to be congruent to arc HJ. And if we have in a circle, central angles are congruent if and only if their corresponding chords are congruent. So if we have our chord DC, chord AB, if they are congruent, notice the sides being congruent are opposite the central angles here. So we can say the central angle here is congruent to that central angle. So it would be angle AOB is congruent to angle DOC. So again, central angle congruent if and only if corresponding chords are congruent. And notice the angles are opposite the congruent sides. So we can use that to our advantage in our given information. For example, if I give you circles J and K here, MN is congruent to PQ, we need to find length of PQ. We are told arc MN is congruent to arc PQ. So therefore, the minor arcs created by the chords are congruent, therefore the chords themselves are going to be congruent. So we can just set these equal to each other. So we have 2x plus 1 gives me 3x minus 7. Then I'm going to solve for x. So to make life easier, I'm going to subtract 2x from both sides. So we get 1 equals x minus 7. And we're going to add 7 to both sides. And we get x equals 8. So now that we know what x is, we substitute it in. Again, we want to find PQ. PQ is 3x minus 7. We now know that x is equal to 8, so we're just going to plug it in. 3 times 8 gives me 24. We're subtracting 7, and I get 17. So PQ is 17 in length. A couple more definitions. For example, if a line segment or ray divides an arc into two congruent arcs, then it bisects the arc. So in layman's term, if we got a diameter or a radius of a circle perpendicular to a chord, then it bisects the coordinates arc. So in this circle here, circle C, the diameter AB cuts through the chord XY. It creates a right angle, therefore it's perpendicular. So now we can say XZ is congruent to ZY. And same with the arc. Arc XB is congruent to arc BY. So if we see that notation where a chord has the little right angle there, we know the chord is cut in half. Same with the arcs involved. So if we know the measure of the arc, the full arc x to y, we just have to cut it in half to find xb. Same with the chord xy, as long as we know it, we know what xy is, we can cut it in half to figure out xz or zy. And if we have a diameter or radius of a circle bisecting a chord, then it must be perpendicular to the chord. So we are told x to our point here, ABC, we'll label this point D. So we're told x to D is congruent to D to Y. Therefore, we have perpendicular bisector there. So cut in half, we have a right angle there at our point of intersection. So angle XDB is 90 degrees. And again, we can use this to our advantage to find measures of angles or segments. So for example, in circle S here, we have the measure of arc PQR is 98. We need to find the measure of P to Q. So PQR is 98. Here we have the radius, and we have a chord here, PR. We have the right angle there. We now know, due to our definition, that if we have a right angle, that chord has been bisected. It's cut in half. When the chord is cut in half, so is the arc. So all I have to do, so PQ is equal to half of arc PQR. So arc PQ is half of 98. So it gives me a measure of 49 degrees. And we also have to find PR. So we are told from point T to R is 6. We know it was bisected, cut in half. So if TR is 6, that means P to T is also 6. So all I have to do is add them together. So PR is equal to 2 times 6, which is 12. So the length of PR is going to be 12. And that should be down here in part B. So again, that was relatively easy. Just double T to R, and we have our full length. Now we get a little more markups here. We have the circle L, we have a couple chords, and we're told about right angles. So, and we have the right angle marks in that figure. So here we have, in a circle, or in congruent circles, we have two chords that are congruent if and only if they are equidistant from the center. So if we have two chords that end up being equally as far from the center point, the chords are going to be equal. So in this case, it would be if LX is congruent to LY, then FG is going to be congruent to JH. And notice these are segments, not arcs. So again, as long as we are the same distance away from the center, then the chords are going to be the same. So as long as L to X and L to Y are the same distance away, F to G and J to H are going to be the same measure as well. So we get to use all these wonderful markups in order to figure out answers here. So here we have circle A, WX is equal to XY, which is 22, and we need to find A to B. So we've got all these wonderful points. Now, here we have chords WX, X to Y. We are told they are the same, so they are congruent. So WX is congruent to XY. Because they are congruent, we know they are the same distance away from the center. So we know that A to B is going to be the same as A to C. So all we have to do is set them equal to each other. So A to B is 5x, and that has to be equal to A to C, which is 3x plus 4. So I'm going to solve for x. We're going to subtract 3x from both sides. So we get 2x equals 4. Divide by 2. and we get x equals 4. Now we were told to find a to b. A to b is 5x. So 5x equals a to b. We know x equals 4, so we just replace it. 5 times 4 gives me 20. So therefore, we use the above definition, set our distance segments equal to each other, solve for x, and apply our answer appropriately with the 5x, and we get 20. Here we have circle H in our second problem. PQ is 3x minus 4, and RS is 14. We need to find x. So QP, RS, here we have segments HT, HU. Both of them are 8. Based on our above definition, two chords are congruent if they are equidistant from the center. They are equally distant by each segment is 8. Therefore, QP equals RS. So we can say, well, in our case, PQ equals RS. PQ is 3x minus 4. RS is 14. So we're going to solve for x. Add 4. We get 3x equals 18. Divide by 3. X equals 6. So again, we found x, therefore we are done with this particular problem. Our third problem here, given circle A, shown AF is equal to GE, or AG, and BC equals 22, we need to find DE. So when two things are equal, AF equals AG. So this means our chords BC and DE are equidistant from the center. Therefore, the two chords are going to be equal. So if BC equals 22, then DE is also going to equal 22. Because of our given segments being equal, we know the chords are going to be the same. So BC equals DE. BC is 22. So therefore, 22 equals DE. Pretty straightforward on that one. Again, when two chords are equidistant from the center, the chords are going to be the same. Number 4, we have a couple different things we have to do here. We have the circle P, radius of 10, with AB being perpendicular to DE. So perpendicular means we have a nice right angle here at the point of intersection. So we have a right angle at point C there. So it's saying if AB equals 8, what is the length of A to C? Well, one of our earlier definitions said if we have a diameter or radius running through a chord, if there's a right angle, then it bisected the chord. So we have a perpendicular bisector. Bisector means cut in half. So if I know the full length, all I have to do is cut in half to find AC. So AC is half of AB, which is half of 8. So 8 divided by 2, or 1/2 times 8, gives you 4. So AC equals 4. Now it says in B, if DC equals 2, what's the length of AB? We were already told AB is 8. So I'm actually going to ignore that. I'm going to cross it off, and I'm actually going to ask you, what is the length of CP? So we have a radius of 10. Again, radius is from the center point to the edge of the circle. So radius here, P to E, is 10. So if that's half, that means P to D is also 10. So C to P, it says DC is 2. What's the length of C to P? So the full way, so we have a measure of 2 and a measure of x, because we don't know what C to P is. So we know 2 plus x is going to give me the radius of 10. We'll subtract 2. So that means C to P is 8. Now number 5 and 6, the last couple here, we start getting into a little more involved stuff that we learned previously that we have to apply here. We are tasked with finding the angle measure of arc CD and arc ED. And we are given 2 parallel chords, an inscribed angle of 65 degrees, and diameter BAD. So from what we have to do, from what we gather, we have to figure out the length of arc C to D, and arc E to D. So first things first, we can at least figure out the length of arc BE. We have an inscribed angle. Again, inscribed angles are half of the measure of the intercepted arc. So the arc created by angle EDB is going to be twice the amount of our inscribed angle of 65. So this means B to E is 2 times 65, so 130. Now B, C, and ED are going to be the same. Now the reason they are the same, well actually, if we look back at one of our original definitions, we are told central angles are congruent if or only if the corresponding chords are congruent. So, and that arcs between parallel chords are congruent. So we can apply that here. So we know that in this case, the arcs BC are going to be congruent to the arc ED. And the central angles are as long as again, the central angles are congruent if and only if their corresponding chords are congruent. So if we take a look here, unfortunately, we don't have central angles in this case. However, fortunately for us, we can use a little bit more information. So we learned yesterday that when I have chords coming off, we create right angles. And that here, actually, you don't even have to go that far. So if I think about this, we technically have parallel lines cut by a transversal here. So here we have a parallel chords cut by a transversal. We know in this case alternate interior angles are going to be congruent. So if EDB is 65 degrees, then that means angle CBD is also 65 degrees. So again, parallel lines cut by a transversal, alternate interior angles are going to be congruent. So again, here we have an inscribed angle of CBD. Inscribed angles are half of the measure of the intercepted arc. So arc CD is going to be twice 65 degrees, which is also 130 degrees. So we know arc CD is 130 degrees. Now we get to figure out the measure of arc CD, or rather E to D. So because we don't know what it is, we can actually label it with an unknown variable x. And because we know E to D is the same as BC, BC is also x. Now, as a circle, we know the full arc around is going to be 360 degrees. So I just have to add these 4 parts, and I will get 360 degrees. So we have 2 x's, and then 130 plus 130 is going to give me 260, and that's going to give me 360 degrees. So I'm going to solve for x, so minus 260. So we get 2x gives me 100. I'm going to divide by 2, so x equals 50. So arc ED is x, so all we have to do is say arc ED equals 50 degrees in our case. So again, parallel lines cut by a transversal, alternate interior angles are congruent. So here we have our angle EDB, 65 degrees. Therefore, CBD is also 65 degrees. Using our definition of inscribed angles are half of the intercepted arc. So to find the arc measure, I had to double it. So arc CD is 130 degrees. And then we use our knowledge about circles to set our equation equal to 360, solving for our unknown x. And we get to do a similar thing here with our final problem. We have arc CB equals arc ED. So arc CB, arc ED are congruent. And it says the ratio of arc BC to arc BD to arc EC is 1 to 2 to 4, and we need to find all these angles. Now it does not come out and say point F is the center. If it was, it would have said encircle F, yada, yada, yada. However, it does not, so we can't take it for granted that F is the center. So first things first, we need to figure out the measure of the arcs here. So fortunately for us, they gave us a clue. The ratio is 1 to 2 to 4. Now we don't know exactly, so we can say 1 would be 1x. So BC would be 1x. BD is 2, so it's twice x in this case. So BD is going to be 2x. And because ED is the same as BC, that one's also going to be x. And then EC is 4 times our initial, so 4x would be the measure of EC. So basically, I just add these up to get 360. So when I add them up, x, 3x, 4x, 8x. So we have 8x equals 360. So when I divide by 8, so 360 divided by 8 gives me 45. So x is 45. So this means BC, arc BC is 45. B to D is also 45. B to D being double is going to be 90. And then 4 times would be, at 4 times x would be 180. So we now know the measure of the arcs C to B, B to D, E to D, and E to C as well. So now what we're going to do is we're going to try and figure out the measures of angle BCF, EDF, and CFE. So BCF is, so here we have BCF, so angle BCF, we got to figure out this angle right there. Now BCF being an inscribed angle, I apply the knowledge of an inscribed angle being half of the intercepted arc. So the arc here, if I follow BCF, I go from B to C to D. So we know arc BD is 90, so BCF is going to be half of 90. So it's going to be a 45-degree angle. Then we're just going to mark it up here. So we have 45 degrees. The next step is EDF. So E to D to F. So here we have our angle. And again, we have an inscribed angle. Inscribed angles are half of the intercepted arc. So if I follow along E to D to F, I see it stops at point C. So if I look at arc EC, we know angle EDF is going to be half of 180, which is going to be 90. So E to D to F is a 90-degree angle. I know it doesn't look it, but it is. Now we have to figure out angle CFE. So we need to get this one right here. So how are we going to do that without knowing for sure if point F is our center? Well, we have to take a look at the fact that we have multiple inscribed angles. So what we really have to do is we have to figure out the other three angles here in order to find our missing piece. So fortunately for us, we have two triangles here. And because we have two triangles, we can go further with that. So without further ado, we know angle E is going to be half of 90, so that's going to be 45. So that means, again, 9 equals 45. Here we have a triangle. 90, 45 makes 35, meaning here we have a 45-degree angle as well. Central angle here, CBE, is going to be half of 180, so this one's also 90 degrees, so we have 45-degree angle there as well. So because we have we have vertical angles, 45-degree angle, then that means these two angles are also going to be vertical angles congruent. So here we have 45 and 45. And then our two unknowns, so two x's, it's going to give me 360. So we have 90 plus 2x gives me 360. We'll subtract 90 from both sides. So we have 2x gives me 270. So if I divide by 2, then that means our angles are going to be 135 degrees. So angle, in our case, angle CFE is going to be 135 degrees. Again, we have the two triangles. We used our inscribed angle knowledge to figure out the two angles that we could. So 90 and 45-degree angles. And then because triangles add up to 180 degrees, that means we were able to figure out our third angle up here at the center, or rather at point F. And each triangle was 45 degrees as well. So again, when two lines cross each other, we create vertical angles. Vertical angles are congruent. So that is why we were able to say that this angle x was also angle value of x as well. Vertical angles being congruent. Angle CFE is the unknown x. Therefore, angle BFD is also value of x. And we know if we go around in a full circle that we will get 360 degrees, which is why we did 45 plus 45 plus our two x's. Again, solve for x, and we get 135 degrees for our angle measurement. So again, this is applying rules of chords and minor arcs along with inscribed angles and central angles to figure out missing pieces.